Wat het ek nou gedoen? There we go. Right, ladies and gentlemen, good morning. This place is driving me insane. So I'll see whether I can move us back to the engineering building. Although not everybody attends class, so we would probably fit in to a 90, 100 venue or something. Okay, I will let you know if that happens. The website. For the moment, please go on to SunLearn. You are registered for the module and click there to access the website for this course. Do not go to cs.sun.ac.za/RW144 because that link is outdated and I'm yelling my head off and I'm trying to get the technical officer to take 5 seconds to fix the bloody thing. Okay, and he's not doing it and I'm upset about it, but that is the situation. I know how to fix it. I don't have right permission in that bloody directory. Okay, so go via SunLearn to get to your TUTs. The TUTs, Narga H, Narga D. Those of you who want extra support from tutors, you go to Narga H until it's full. The rest of you in Narga D. You may do the TUTs at home or in the lab. If you do it in the lab, you have a place to ask questions. If you prefer to do it on your own, it's fine by me. The TUTs each have four or five questions. For those of you who are learning to program still, aim to finish the first one, maybe two, in the 3-hour period on Thursday. And the idea is that you do the rest in your own time. It's simply exercises, right? It's to help you program. The answers are there already, all of them. Test 11th of August, Thursday afternoon, 2 o'clock. Narga D and, oh my word, Narga D and H. We should fit in. Meneer Stigling, stuur my e-pos dat ek kyk of die toets, of ek 'n groot genoeg toetslokaal kan kry vir die oorvloei. Okay? You must look at the project in the meantime. Yes, on the new page, not the old page. Okay, right, so Opski. Where are we? We are, excuse, wil enige iemand interpretatie van Engels na Afrikaans? Nee? Thank you very much. Right, so where are we? We are building our own types, our own data types. Java has built-in primitive types, yes, like int and bool and char. We want to make types for exotic things, like colors, and pictures, and particles, and so on and so forth, right? Because that enables us to argue on a higher abstract level about the workings of the program. The difficult thing with object-oriented programming is to design, yes, to think in an object-oriented way. Because up to now, you're used to thinking about variables and adding and subtracting and ifs and whiles and so on. So it's a rethink in the design process. So let's see what we did on Monday. It works quite similar to normal variables. To use objects is quite similar to normal variables, and that's the problem, because it looks so familiar that you want to use it exactly the same way. Right? There are subtle differences. You need to understand the memory access. So Let's have a look. Suppose I created my own type, which I call charge. So I write the Java file charge.java, note the capital letter. Then I have all the methods that can do something with the data type charge. I always include a method toString so that I can print my values. And then there is something called a constructor, okay, which will create an instance of that object. Right, so let's look at the example. You have to know what happens in memory. And I'm busy setting the test. Question 1 for 10 marks is, give the definition of all the usual new terminology that we're using. Yes, what is a data type? What is a value? What is an object? What is a blah, blah, blah? All these things we're doing. Yes, that's question 1. Question 2 is, look at this nice piece of Java code. Here is empty memory. After each statement, tell me what the memory now looks like. Okay, like this. If this is my Java program and I have an object charge, if I have a data type charge, yes, I declare a variable. Once I declare that variable, memory will have a block called C1, which will be empty. Yes? After that statement, that memory block will be empty. C1 will be there, but the memory block will be empty. Then I instantiate one such object, yes, by using the constructor. So variable name equals new. New creates this thing for me in memory. Yes, so what does it do? This is my constructor, charge. It comes to memory. All that is in memory at the moment is C1, which is empty. Then space is found, which is large enough to hold one instance of that object. Yes, in our case, we need 3 numbers. So the computer looks and it finds space for 3 adjacent floats, yes, underneath each other, and it found that space at address 459. And then it writes 459 into the block next to C1. You with me? This is a pointer, also known as a reference. That 459 is an address. It's a memory address or a reference, and it points there, and the values are written in. Deceptively simple. Yes. Now, what would happen if I declare another object? I rephrase. If I make another variable of type charge, and I call that C2, I would get, the code is not here, right? I would get another C2 variable. That thing will be empty until I call the constructor for data type charge, yes. Then empty space is found, in this case, by, for example, at position 611, address 611, and the value 611 is filled in. Now, every time that I use C1 or C2, what happens? The program sees C1. It finds the variable name C1 in memory. It looks at the reference address. It goes there. That is my address. I go there. Like what, 3 words? Huh? I go there and I can find the values that constitute my objects. Yes? Now, how do I call the methods that is available for my object. Here is an example of a method, yes, that is available for my newly defined data type. It's called potential at. Yes. So every time that I have a variable of type charge, I can call potential at for that variable specifically. Therefore, I could write a program which says for variable C1 of type charge, please call the method potential at. And when you get to the implementation of potential at, the values that I will use to calculate are these values that belong to that object instantiation. If I say W equals C2 dot potential at, then these values will be used. Yes? Looks easy, right? Right? So, but that's the thing about programming. You look at the general concept, it looks very easy, and then you start using it and you get to all sorts of snarls. Okay. So how do I use objects? Basically, I declare this new data type. I then declare a variable. I construct an object. Yes. And now I can call the methods that operate the operations on that specific variable of that type. Okay. And you can use them now like any standard variable. So I could use them as return values, I can use them as arguments to a method, I could use it in an assignment statement, I can put it into an array, I can have an array of objects. So everything that you've learned up to now about variables, you can put an object in there. Okay? Works the same. Type conversions. Now. You know that Java does automatic type conversions on primitive types. So for example, horrible style, don't ever do that. But you could store an integer in a double. So I have a double x and I have an int y, and then I can say x equals y. So I assign the value of y to x. But a type conversion occurs. Yes, because I had an int, say 1. No, make it 7. I like 7. I had the value 7, which was an int. Now I store it in a double. Now it becomes 7.0 automatically. Yeah. It shouldn't be allowed, but okay. In fact, normally I force my first-year students to only allow explicit type conversions. So you have to convert every time you want to do something like that. Otherwise, you get unexpected results. Okay, now how do I convert between types of my own making? Yes, primitive types make sense between an int and a float and so on. But how do I convert a charge into a date? For example, day, month, year. Well, it's silly, why would you? So if you want any type conversions which are allowed on your own defined reference type, you have to program it as an operation in your object implementation. Okay? So you have to do it explicitly, right? And you as a programmer have to write that code. But in general, the only conversion we really like is to string so that I can print the values of my type. Okay? Right, what can go wrong? So let's consider for a moment, I have this nice new data type, charge, and now I want to declare a variable and calculate potential at. So what do? I have charge, so I can declare a variable. Yes. And it's a bad pun, but okay, they call it bad. And then I say V equals bad.potential. Oops, why can't it work? That cannot work because I never constructed an instance of that thing. I have to say new. Yes, I have to make one. This is just the type. It doesn't give me the memory space where I can work. So you have to construct first. You have to call the constructor and create that memory space where you can work. Okay? Incidentally, it's very nice to actually program this. So go on Thursday afternoon and see what the error message is that you get when you try to write this Java. Because once you've seen it, you won't make the mistake again. Okay? Right. Now, let's look at the difference between an instance method and a static method. Yay, definitions, terminology. Yay, a mark in the test. Yes? Okay. Static methods are the things that you've used up to now, because how do you know that? It has the word static there. Public static void main, public static my own little method. Yes, you had to have that static there, because that indicates to the compiler that this is a static method. It is simply a function. You must think about a static method is just a function. It's just a calculation on your data types. Yes, on your primitive data types. An instant method is written specifically to work on objects. Okay? So within, we'll have a look at it. No, wait, let me go forward a bit. No. Next section. I just want to show you the code. Here is an example of an object that was implemented to, as a complex, I want to implement complex numbers, right? You all know what complex numbers are? Square root of -1. Okay. So I have an int and I have plus I something, right? So I make an object called, I make a data type called complex to implement my complex numbers. Inside this data type, I have operations and I have constructors. Yes, here is an example of operations. This is my constructor. See, complex. So this thing is my constructor. It makes a variable for the real part and for the imaginary part. And then over here is an operation, plus, times, apps, and so on and so forth. Okay? Note, no static. So inside the code that implements the object, we will not write the word static. Okay, because it's not static. This is an instance method. It's an operation on my own reference type. Okay, so the word static does not appear there. Okay, so for the moment, we're simply looking at the difference between a normal method, if you want, a static method, and an instance method. The purpose of an instance method is to implement an operation on the value of a given object. The static method is a function. It computes a return value. It computes. Yes, on normal variables. The parameters here is there. Now, the the calling to the instance method versus the static method. With the static method, I just put the class name and the name of the method. Like when you call square root, you have to say, what is my library name? My library is math, and I want to call math.square root. Yes? If I have an instance, that math there is the name of a Java file, it's the name of a library. Over here, when I call my instance method, I I put a prefix, which is the name of a variable of that reference type. Yes, so this is a variable name. I don't write capital charge dot potential at. I declare a variable C1 and I put that in front. Yes. Okay. So that's the usage. Now we have a number of examples, which I'll quickly go through, but I expect you to actually read this yourself. It does exactly what we talked about now. Okay, so available for us is an object called color. Yes, and you can find that in java.org. So if you want to use colors, you import java.org.color. I think you've done that in the first semester anyway. No? Okay, well, this is cute, so you can do that. What is a color? We are just talking about red, green, and blue, combinations of red, green, and blue. So every variable that I declare of type color, can you see this? This is a reference type. Yes. So red will become an instance of an object. So this is a variable, but not of a reference type, so it's an object. So I must new it. Yes. Okay, and I do that. And now you can draw all little cute programs. Whatever. It's the use of the thing. If I import java.org.color, I can get to red, green, and blue values, and I can assign that to different variables. And I have colors available, which you will use in your project, just like this. Yes. Okay. Right. And there is the API for color. There are all sorts of nice things like if I have a color and I don't know what it is, I can get the red, green, and blue components. I can make it brighter, I can make it darker. I can convert to strings so that I can print it out. And I have an equals. Now, this is an important point in using objects. For example, with the charge, you cannot simply say if C1 equals C2, because reference types don't have these built-in Java shortcuts. Yes, so I cannot say if bracket C1 equals C2, close bracket, because equals has not been defined on a reference type. So within my reference type char, I would have to implement a function called equals. And then I can send it to variables, and that instance method will check, is the X the same, is the Y the same, blah, blah, blah. Okay. And you've seen a bit of this in strings. Yes. Remember that strings are a bit different. Okay. Right, I'm not talking anymore about this example because it's just how do I convert things to grayscale and so on, self-study. Okay. What you have to learn about from this is how we use the objects. Okay, so now I've built a library called Luminance with all sorts of stuff, but the issue at hand is there is an object There is a reference type color. I can use it to declare variables. If I do so, if I want to work with that, I have to new it. I have to call the constructor, yes, with appropriate variables. And there I have a variable of type color. And now I can do with it whatever I want. Okay? The other one, which you will meet tomorrow afternoon in the chat, is this is always nice to do some image processing. You can show whoever, your granny. Yeah? I always use my key as an example. So you can show your granny, who's paying for your class fees, by the way, actually what you're learning at varsity. Yeah, you can make pictures. If you can do a visual thing, people who don't know about programming are always more impressed by a visual than by something else. I remember in my third year, I had a boyfriend who was an engineer. And our task was to implement a protocol. It was these old teletype terminals. Yeah, the things with the green screens. Okay, so it's black and there's a green number on it. And I was like so excited because I've worked on this for weeks. And I demonstrated it to this guy. And I typed an A on the keyboard of the left-hand side terminal and an A appeared on the right-hand side terminal. And he said, so what? So I broke up with him. Okay. Images, how do images work? Blocks, pixels. Oh, shit. I put on the wrong t-shirt. I have a pixel t-shirt as well. Okay, pixels. My skirt has got some pixels on it. Okay, pixels. Any image you can divide into a grid, and every block is a pixel, and that pixel has a color, red, green, blue. Incidentally, for those of you who are interested, read up on color schemes, because red, green, blue is a really silly thing. If you want to do decent color processing things, then you go to the other color models, like HSV and so on. There are 3 or 4 of them available. You can convert between the two as well. Right, so how do I manipulate images digitally? Because I now want to impress my granny. What is the object at hand? The object at hand is a picture. Yes. So imagine that there is a data type which is a reference type called picture. Incidentally, there is, and you will use it tomorrow afternoon in question 2 of the type. It has a constructor. Actually, it has 2 constructors. Do you notice the overloading? I can either give it a file name, or I can create a blank picture. Yes. Of a certain width and height. The width and height specify the pixel depth, right? And I can ask what is the width, an instance method that returns an int, the height. I can get the color. I can set certain colors. Ooh, look how nice this is. I can mix my objects. Because remember, color is an object. So I can use one object in the implementation of another one. Okay. I can show, I can save, and so on and so forth. Show in this case refers to string, because you don't want a string representation of your picture, you actually want to see the picture. Okay, there we go. Just note, 0, 0 is top left, not bottom left. Otherwise, your pictures are all upside down. Okay, there are methods for grayscale. So let's look at using pictures and color. I want to use pictures and color, so I import java.org.color. And this is now a little thingy that can take any image and convert it to grayscale. I use picture for that. Right? So the data type picture, I declare a variable pic of data type picture. Oh, it's an object, it's a reference type, therefore I have to new. So now I new. Yes? And this is clearly, is this reading a file name, or is this using a blank, is this making a blank picture? One argument, therefore it's a file name. There should have been two arguments if it was with the knife. Okay? And then I can go through the picture and I can look at the color. So I can get the color for pic at XY. And I can use that luminance thing I had previously to convert that into gray. And then I can set pic to gray. Now wait a minute. I'm making a bowl of spaghetti here. Do you notice these subtle differences? Let's see. Luminance. Why am I using the class file name here to call to gray? Whereas there I use pic dot.
Because it's a library?
Yes, exactly. So here you see the difference. I have a pic variable, which is a reference type. So I can call an instance method. Over here, luminance was this little library that we implemented there. No, not objects, because these are not instance methods. This is a library, yes, because it's got that static there. Okay, everybody happy? Okay, work through it and play with it. This is actually fun. You can also scale images, yeah. This is a bit what, how many of you use iMacs or MacBooks? They have those funny, you see this nice machine. But okay, they have the thing I did many moons ago when I got my first iMac is you can take a picture of yourself and then there's these effects that you can do, like you skew your face or you make fat little cheeks or things and then you post it on Facebook. But okay. So you can take a picture of someone you don't like and then scale it. Yes. Put it on Facebook and see what happens, right? Please go through this. Go through this code and make sure that you can figure out where am I using objects, where am I simply calling static methods, okay, and the difference between them. In this case, I'm only working with source and targets using the reference type picture, and the only operations here are on source and target, so I'm calling instance methods all the time, right? Okay. Ooh, this one is so cool. I just love these. Morphing. Yes? There was a few years ago, about 5 or 6 years ago, that was the in thing for TV adverts. Yeah, you start out with the source picture and a target picture, and then you slowly morph the original picture to the target picture. Okay? Right? And that is exceedingly easy to program in Java. There you go. They call it the fade effect. But basically what they do is they have a source and a target. Right? So you start out by taking each corresponding pixel. That's the two images must be the same size, same width, same height. Then you take the corresponding pixels and you do a linear interpolation between them to get the next stage picture, and then you do it again, and then you do it again, and that's it. As easy as that. And I think it's fairly impressive. You know, your BA roommate. Go impress them. Nerds should be able to do cool things. So I have nothing against people who do a BA. I've done a couple of BA subjects myself. But anyway. Or your first year girlfriend. No, your first year, damn it. Your third year non-programmer boyfriend. Okay, right. This one, I don't like this example, so I'm not doing it, but you can read through it yourself. Now, the interesting thing. You've, alle grappies op 'n stokkie. You've been using strings without us telling you that you're actually using a reference type. Because a string is a reference type, it's not a primitive type. Yeah? And you would have used things like the length, char at substring, index maybe, concat compared to. If you don't believe me, you should try this one. In the first semester, you might have stumbled on this one if you want to see if two strings are equal. Yeah. You get all sorts of interesting effects. Okay? So these are some of the instance methods that you can use on a string. And please note, I hate shorthands, but okay. Java allows you to write string s equals with a literal string there, which is silly because it takes away the idea that you actually need new string ABC. That shorthand should not be allowed because strictly speaking, string is a reference type, not a primitive type. So you could have gotten used to that constructor. Okay? And the other shorthand that I've been implemented is if you want to concatenate two strings, you can plus them, which is anyway a ridiculous notation, but okay. Which is equivalent to .concat. Okay? Put them next to each other. There should be one way of doing things. And programming languages always allow a number of ways to do things. So for a style guide for yourself, find the way that you prefer to do things and use only that. Yes, for consistency in your programs. So if you always use the shorthand, then we'll stick to the shorthand. Don't use this and then use that. And it's much more difficult to find bugs and to read your program afterwards if I have to mark it, if you switch between conventions. Find a convention that works for you and stick to it. For example, I never use for loops, I only use while loops. Mathematically, it's much easier, so be it. And if in a loop you start somewhere, for heaven's sake, at 0, upper bound always as a or less or equal, but don't mix them. Some loops is less or equal, loops is less. Then when you find a bug, trace and find. Okay, please note, there is a difference between an array and a string. Why would that be? Because with an array of charge, you are using the reference type array and you're putting single charge in it. So if you want to manipulate them, you can use the ith index. That is how charge arrays work. If you use a string, yes, you have the reference type string, and if you want to find a specific element, the correct way of doing it is to use the provided instance method, char at position I. So deep down, subtly, it's two different things. Okay? We tend to mix them. Okay. A number of sweet little programs. So what I might do in a test is to use some of these example programs. You all know what a palindrome is. A word that reads the same from the front and from the back. I'm better in Afrikaans with palindromes, but okay. I'm ancient, so ABBA used to be a rock and roll group from Sweden, yes, ABBA. And it reads the same, ABBA, ABBA. And mathematically, palindromes are exceedingly interesting numbers. Yeah, because when is a palindrome? How do you create a palindrome, and so on and so forth? Interesting reading, if you're interested in numbers, which I am, and patterns in numbers, there's a sweet little penguin book, and it is on Amazon as well, electronically. The Penguin Dictionary of Curious and Interesting Numbers. And it's that little thing that when the conversation is really boring you because people are talking about persons from People magazine or Huisgenoot or whatever, then you take out your little book and you read your Dictionary on Curious and Interesting Numbers. For example, what is the largest known useful number? It's a Googleplex. It's very huge. And then 31 is the first number that is totally non-interesting, and therefore it's very interesting, but it's actually non-interesting, and so on. It's useless things amuse me tremendously. Okay. Right. Please look through these examples of code, just like in the first semester. I assume that you can write this. Okay, so I might use it as examples. I won't ask you to write the code to read a palindrome. I just assume you know what it is. If I use it as an example in a test, you know how it works. Here is an interesting thing. Print all the hyperlinks of the strings on the standard inputs. How do I break up strings? So you use the string object, and then you can have starts with, you can have ends with, and so on. And then it's very easy to check for legality. For example, how many of you can write mobile apps? No, one or two. You always have to check these legal things. Yeah? Are you interested in writing apps? Who of you would like to be able to write apps? Oh, yeah, die hele wêreld, ek sien. Okay. May I use CS Stoked? Who asked me yesterday about CS Stoked? Yeah. You did 3D last semester. Shall we do apps this semester? Yeah. Okay, so CS Stoked will happen again this semester. I'll just figure out how many people want to do it and we fit it into the tutorial period. So that's where we do extra things. Meneer Stigling, stuur my e-pos dat ek double check of die software geïnstalleer is in Narga. Ek het verlede semester gevra, ek weet nie of het al op is nie. Okay? It's a pain in the royal, yes, but once you get the thing going, it's not as mysterious as it sounds. Even I can do it. So. My son got a programming job from a friend of mine writing an app. And then he got bored halfway through, and I was actually seriously feeling the obligation not to let my friend down. So I wrote the answer now. Anyway, okay, nice one. We've got 5 minutes, and I'm almost making it. Genomics is a very interesting field. How many of you are doing biology? So there's this huge field called bioinformatics, and it's all about finding patterns in huge fields of data. Almost all science fields these days collect masses of data because they can, and they store it on their terabyte hard disks, and then they throw up their hands in the air and say, now how do I process this? Okay. So, for example, I'm working with some nature conservation charities who are tracking things like leopards. Yes? Many, many interesting. Any other thing apart from computer science that you think you're interested in, you can do this, right? And it's all about masses of data, finding patterns in masses of data, right? Do you know? Okay, we can do this on Friday as well. But so I'm working with botany. One of my honor students is doing a project to actually look at the data that they've gotten on oxalis species, in Afrikaans sierentjies, oxalis, because some of them are really, really endangered, and others of them are just exotic weeds, but okay. So they want to know where all the populations are. So now they walk in the veld, the life of the botanist. They walk in the veld and they say, oh, wow, look, there's that particular species that I'm interested in. But they only get to the road. So if you look at their data, basically you see all these patches of endangered species that are next to a road. Okay. So what we are now doing is writing modules that analyze all the parameters that are relevant, like soil type, weather, elevation, and so on and so forth, and do machine learning on their data so that we can predict where other endangered species might occur. Okay? So it's all about the patterns, it's all about the data. I'll look at genomics because that's cute on Friday, and then we'll finish section 3.1 on Friday. Yeah. Yes, so.
Hi guys, before everyone else goes to the other classes, the ASC informed the class reps to pass this message around, but I don't think anyone's been told. Basically, if you have goodies that you still haven't collected, today's the last day. You can pay for them and collect them the same day